Introduction to Graph. Types of graphs. You've learned about different types of graphs. Look at the graphs given here. Why do we use such graphs? The purpose of these graphs is to show numerical facts in visual form so that they can be understood quickly, easily, and clearly. Thus, graphs are visual representations of data collected. Data can also be presented in the form of a table. However, a graphical presentation is easier to understand. This is true in particular when there is a trend or comparison to be shown. As we know, there are different types of graphs through which we can represent data. Now let's recall types of graphs one by one. Let's consider the first graph. What do we call this kind of graph? A bar graph. A bar graph is a graphical display of data using bars of different heights. This graph shows number of visitors to a park from the year 2010 to 2014. It helps us to compare and tell the variation in the number of visitors to the park in 5 years. It is clear from the graph that in the year 2012, the number of visitors is the highest. And in the year 2010, the number of visitors is the least. Bar graphs can also have double bars. For example, this graph shows the comparison of fruit choices of 7th and 8th grade students. We can also represent this in two different graphs, but it is easier to compare if we use double bars. Now look at the graph shown here. This is a pie graph or a circle graph. A pie graph is used to compare parts of a whole. The circle represents the whole. This pie graph gives the percentage of oil reserves by region. From the graph, it is clear that in the Middle East region, oil reserves are more. In which region oil reserves are the least? By looking at the pie chart, we can see that it is least in Europe. Another way of representing a data graphically is through histogram. A histogram is a bar graph that shows data in intervals. It has adjacent bars over the intervals. Histograms are similar to bar graphs, except that there is no gap between the bars. There are no gaps between the bars because there are no gaps between the intervals. This histogram gives the height of the students for 8th grade. We can observe that heights of most of the students lies between 155 to 160 centimeters. Line graph. Here we have a few graphs. These are called line graphs. From the data represented in each graph, can you infer the type of data generally represented by line graphs? Each graph shows a trend followed in successive years. The first graph shows the population of literates of country C from year 2006 to the year 2014. In this graph, the trend shows that there's a gradual increase in the number of literates in most of the years in comparison to the preceding years. The second graph shows the number of cars sold from January to June. In this graph, the trend reflects mixed results. For some months, the sale is high in comparison to the previous month. However, For some months, there is a decrease in the sale of the cars. The third graph shows a comparison of values of sales of 3 different products in the year 2004. For each of the product, X, Y, and Z, the trend is different. Thus, we can say that a line graph displays data that changes continuously over periods of time. Let us learn to read and create line graphs. Let us first see how to read a line graph. Consider this line graph. The x-axis represents the constant information, which in this case is months. The y-axis represents the variable data or frequency, which in this case is the number of cars sold. Notice that corresponding to the month of January on the x-axis, the number of cars sold on y-axis is 20. This correspondence is represented as a point on the graph. Now, in the month of February, the number of cars sold increases to 35. Hence, the increase in the number of cars sold in February is 15 more than the month of January. However, in the month of March, the number of cars sold is 10 less than the preceding month, that is February. Thus, we can easily study the trend in the data plotted through a line graph. Can you identify for which month was the number of cars sold the highest and for which month the number of cars sold was the lowest? We can answer this by looking for the highest and lowest points on the graph. The highest point on the line graph shows the maximum number of cars sold. This point corresponds to the month of May. And the point at lowest height shows the lowest number of cars sold. This point corresponds to the month of January. Therefore, the number of cars sold was the highest in May and was the lowest in the month of January. Can you identify from the graph which months show the maximum increase in the number of cars sold in comparison to its preceding month? The maximum increase in the number of cars sold is in the month of February and April. Let us now see how to create a line graph. Here we have a data in the tabular form, which shows the temperature of a patient in a hospital recorded every hour. Let us represent this data in the form of a line graph. Let us take the timings at which the temperatures were recorded along the x-axis, that is, horizontal line, and the temperature along the y-axis, or vertical line. Observe a jagged line along the vertical line. This broken line indicates that the line graph is not showing the temperature between 0 and 34 degrees Celsius. Let us plot the points for temperatures at different timings as shown here. Now join the points with line segments. This is the required line graph. What does this graph tell you? You can see the pattern of temperature. It is maximum at 11 a.m. In the interval of 10 a.m. and 11 a.m., the temperature increased to maximum. Let's take another example. The following line graph shows the yearly sales figure for a manufacturing company. What were the sales in 2002 and 2006? In 2002, the sales were rupees 4 crores, and in 2006, the sales were rupees 8 crores. Compute the difference between the sales in 2002 and 2006. The difference between the sales in 2002 and 2006 is 4 crores. What were the sales in 2003 and 2005? In 2003, the sales were rupees 7 crores and in 2005, it was rupees 10 crores. Here we have a graph which shows the temperature forecast for each day of a week. The actual temperature is different from the temperature forecast. Let's say the graph of actual temperature is as shown here. If you are asked to compare the data of these two graphs, it will be time-consuming for you to study both the graphs separately. And as the data represented in both the graphs is for the same time period and for the same variable, we can merge the two line graphs into one. Thus now, we can compare the actual temperature and forecast. Here we have the graph which shows both temperature forecast and actual temperature. The graph is a double line graph. Graphs that have double lines in the same graph are called as double line graphs. Let's take an example. For an experiment in botany, two different plants, plant A and plant B, were grown under similar laboratory conditions. Their heights were measured at the end of each week for 3 weeks. The results are shown by the following graph. Let's try to answer a few questions by observing this graph. How high was plant A after 2 weeks and after 3 weeks? From the graph, it is clear that after 2 weeks, the height of the plant A is 7 centimeters. After 3 weeks, it is 9 centimeters. How high was plant B after 2 weeks and after 3 weeks? Observe that after 2 weeks, height of the plant B is 7 centimeters. After 3 weeks, it is 10 centimeters. How much did plant A grow during the 3rd week? Plant A grew 2 centimeters during the 3rd week. How much did plant B grow from the end of 2nd week to the end of the 3rd week? Plant B grew 3 centimeters from the end of 2nd week to the end of 3rd week. During which week did plant A grow the most? During the 2nd week, plant A grew the most. During which week did plant B grow the least? Plant B grew the least during the 1st week. Were the two plants of the same height during any week shown here? Specify. Yes, at the end of 2nd week, the two plants were of the same height. Let us summarize what we have learned. A bar graph is a graphical display of data using bars of different heights. A pie graph is used to compare parts of a whole. The circle represents the whole. A histogram is a bar graph that shows data in intervals. It has adjacent bars over the intervals. A line graph displays data that changes continuously over periods of time.